Hello guys. We're going to continue trying to help Art out with his radio. We're going to look at some details about testing, or a way I would like him to, or show him a different way of testing the IF transformer. Right now I got this radio hooked up. This is a Firestone, old Firestone radio. I got it hooked up to the generator. Now, right now I'm running unmodulated signal in, so it's a little more clear. This radio happens to be have an IF of around 465, but it doesn't matter what the IF frequencies are. The test is still valid. And I'm going to show some shortfalls and some other things, but right now I'm feeding into basically the grid cap, or right here, which is going to the grid cap of the mixer tube. And we're picking up just out on the grid cap on our IF tube. So all we're doing is just going through the first IF transformer, and this is our signal right here. Now I'm going to adjust frequency, taking it off. Now it has actually a double peak. A lot of that's because of the local oscillator. But when I get coming up, right now at 459, 460, 465, but as I adjust that frequency, you can see that it I'll take it on up to about 500. So it's pretty peaked out pretty good at 465, roughly, give or take. And if I turn on the modulation, there's what the modulation looks like. And you can hear it. Now, this is the best way to test it, mainly because of all the other circuit elements that's in the circuit. This will get you close enough to knowing if your peak frequency is correct, or close anyway. Now I'll show what happens if we move this out of here and we take it. Don't mind the camera work. There's ground. And we're going to hook right onto this cap, which is hooked to the plate. And now I got to adjust down because I'm not amplifying the signal anymore through the mixer tube, so I have to take her down. When you connect there, you're going to find a total different peak, and a lot of that has to do with all the other circuit elements in here that will affect your frequency. In order to really test it and check it, you need to go back up to the grid and feed into the grid, and that's where you can find your peak, true peak, and where it's, or at least getting pretty close. Now again, you may have a double peak. A lot of them do. So, but I'll show you what happens. It should peak out somewhere around 380 or so. We're going to start taking it down. Alright, about in there. We're peaking. But a lot of this is a back feed back into, and I'll show you what I mean in a minute. Come up. Looks like we're about peaking, so that's around, we're on this scale here, there's 350, 60, 70, 80, about 390. But actually, it's reading somewhere around 660 because there's a back feed feeding back through that capacitor coming back to the meter, so I'm getting a little standing wave. Now, one way I can probably help that a little bit is if I terminate this, put a 50 ohm resistor on here, or even add and make a divider even and put another resistor in here at the end, but at least get it terminated with a 50 or 47 ohm because it's 50 ohm cable. It would kind of reduce some of that back feed. But so when you're expect this to happen if you're going to be checking it here at the plate, which is basically hooked right here, so we're feeding right directly in, because we're going to pick up our local oscillator, and we're going to pick up some other signal, and we're going to get some back feed because this is a strong signal coming out that's going to back feed back up our cable. So now we'll reconnect it back up here to where we were at before. And of course it still has a little bit of that back feed, but we'll bring her back to our true peak around 465. So be aware that you can have some of this. Like I said, you could probably, do a termination and it might help some, but you can have some troubles with it. So be aware when you're checking it. The main thing about the scope is, though, is not so much at this point trying to make sure that your frequency is correct, as much as making sure you're getting a signal through. Because the nice thing about a scope is it's very sensitive, so it will allow you to see something there. If anything's getting through that IF can, you'll be able to pick it up and see it. That's the beauty of it. And run your generator pretty much maxed on. We're not going to worry about, you're not doing alignment, so you're not worried about the AVC kicking in. You're not worried about swamping anything. The main thing is you're trying to make sure that you can get a signal through that IF can. Now, we're going to talk about some things. We're going to talk about another way of testing stuff. So I'm going to set the camera down and kind of get myself set up here and kind of show you. We're going to look at an IF can and how it disconnected. You can check it out. And shut a radio off. And disconnect everything. Now, I got it hooked up. Basically, we're feeding a signal into this IF can. Let me move the schematic out of the way here, because I want to look over that here in a minute. But I've got the scope hooked up to the grid cap. We take two sides of the coil, basically where B plus would feed in, and the ground side for the other. We tie those two leads together and bring them to the can to ground the can to our signal generator, and then we take and of course hook your scope negative up to there too. Feed the signal into the can, basically on the lead that would go to the plate. It doesn't matter a whole heck of a lot if you get those reversed, but you feed it in there, you're getting your signal out there, and you get this signal here, and you can kind of get a general idea. It's not perfect on checking for where it peaks out at, but you can get pretty close. You may be a few kilohertz off depending. This one's supposed to be a 465 also, or no, it's 460, but it seems to be, and it may be out of adjustment a little bit. You can't really adjust them this way, but it's peaking somewhere around, let's get it right here, around about 430. So it probably is out of adjustment. It was one that came off a radio I'm working on. I've had this one apart and cleaned up it had some serious corrosion on one of the capacitors, so I've had that all completely apart and cleaned up on the trimmers. So it's probably not quite in adjustment. And until it's in the radio and powered up, you really can't really truly adjust them. But it will give you some idea if you pull your can off and hook it up that it's feeding through. Now, what do I mean by hooking these wires up is, if you look at a IF can, you got two coils, and you got, basically, let me get this set down here and do a little pointing if I can. So you've got one wire leading up to one coil. So I got this wire here, and then this is the other wire. And then of course on the other side you've got the same thing. So you want to take two of these. This happens to be ground, and this one, like this one here, because that goes the other coil, and tie them together like this, and hook your ground to that of your signal generator and your scope. And it's best if it's in the can to help shield, and go ahead and hook that as well to ground or negative, just like I did here. So that's what you're doing. One end of each coil has to be connected together, and then hook all your negatives and the can all to that point, and then you can feed your signal in to your plate lead and pick it up off with your scope probe on your grid lead, and then you'll get and see if it's working. You'll get a wave like this. If it's outside the can, you'll pick up some feed through from the signal generator itself from here to here. Now, one other thing I want to show you on this before we get into some serious troubleshooting here, or at least talking about possible problems, and these are very possible problems. Let me go ahead and set this down and get everything hooked back up that I had hooked up before, but this time we're going to do something a little different. But we'll talk about some possible problems you might be experiencing. These are kind of, really at your point, these are kind of a more far-fetched, or at least more way out in the left field type thing. Alright, we're hooked up, yet I'm getting a signal through and the radio's shut off. I have the radio shut off, but I'm still picking up a signal. Now it's going to have its different peak, but I'm not concerned about where it peaks out at this point. More concerned, this is another way with leaving the can in that you can actually check it, because basically what we're doing is we're still connecting up like we did with this here, the can outside the radio and disconnected. We're connected here, feeding a signal in and picking up a signal here on the grid. You know, and everything eventually goes to chassis ground. You know, you go through your power supply, through the filter cap and everything back to ground. So I can hook ground up to ground, both on the, you know, both sides, and I'm fine. But it being that we're still floating through some various capacitances, we've got filter caps that we're going through, we've got decoupling caps here, and you got your various other circuit elements and capacitances in there. It's going to not, with the radio shut off and not hooked up right, you're not going to get, you know, you're going to get a lot lower frequency, somewhere around that 390 area or somewhere, probably, or in that general range of a peak. And that's because we got a bunch of extra capacitors and circuit that's inside the radio that the can is still hooked to, or the IF transformer. Now, say you hook it up and you're still getting absolutely nothing. Then there is something seriously wrong with the IF transformer. If you get zero signal through it, then there's serious problems, and you can't find any signal no matter where you adjust your signal generator at. You're still not getting anything. That transformer's is bad. It may check good for as resistance on the coils. It may check good as far as, or what seems to be good as far as capacitance on the trimmers. They may seem to be adjusting, you know, changing capacitance and everything, but there's something seriously wrong with that transformer. Now, what if you get a signal but it's extremely weak? What kind of problems could you have that could cause that? Well, we're going to look at two, and this is way in left field here. Look at two things here. One is the possibility, more or less on the secondary than primary, but you can try this on the primary because it's the easiest one to switch. But is one of the coils need to be flipped to bring it in phase so it's working properly. Actually, they're basically, most transformers are wound out of phase, and there's a reason for that. Is it has to do with counter EMF and how it phases up in its phase and everything. But in any case, when you had all this you took it all apart and you put it back together, if the wires are not, back where they were, it's, like I say, an extremely ballpark area. Or left field area. It's really way out there. The only ones I've ever seen that can cause problems like that is secondary IF transformers that are center tapped. I've seen that if you flip these two wires, if you disconnect, take the the coils out and then rehook them back up, and you get these two flipped, where you got a center tapped that goes out to the diode, these can cause problems. But you're working with one like this, and I mean, I could do the flipping in here and show you, but it really makes no difference. But, you know, we're drawing at straws at this point. So that's one thing, and the quick way of doing that is just temporarily flip your plate and your B plus wire. Because if one of these, if you need to flip one coil, that's the easiest one to do, because the other one may be a little more difficult. Although it's the first IF, you could actually do it, but you got the grid cap, so it'd make it a lot harder. Going underneath the radio and flipping these two leads would be a lot easier. The other consideration is, and although this is not really, this is another left field thing, is you took them out, you took that IF transformer out of a much larger can and put it in a smaller can. And although these cans are aluminum, and really the effect shouldn't be much, it's possible, especially if the can is not grounding extremely well, that there's some coupling. It could even be capacitive coupling with the coil sitting closer to the shield that could be happening. Again, really way out in left field. I've only seen it once that I can recall, and it was a total different design than what these are. It was also a core type. It wasn't, you know, they adjusted the magnetic core in the coils. But, and those cans were tin. They were more like a steel tin, metal instead of aluminum. Aluminum doesn't like passing magnetic field too readily, so generally it doesn't really give too much trouble. But and the way to check that, even if you thought that could be the possibility, again though, the only thing it's going to do is weaken the signal and broaden the bandwidth out. It's going to increase the coupling between the coils. So it should still get a signal through, it's just going to be a little weaker. But it'll still be strong enough, the radio should work, and it's going to be a lot broader, so it's not going to be as selective. It shouldn't shut it completely down unless there's a short, and that, you know, that's always a possibility especially on the grid side, that somehow maybe one of these leads or something is shortened to the can. That is a slight possibility, but in either one of these two, you can check real quick and see if you can get it operational by just removing the can. Leave the coil, leave the transformer connected up. Not a way to run the radio, but you can turn it on and see if you get a signal through. Being you got tube shields and everything else is quite shielded on the radio, you shouldn't get a whole heck of a lot of feedback through. Unlike a radio that don't have tube shields, those type of radios, you would probably start picking up some serious feedback, causing problems. But that's something that you can check. Now, what else could be wrong? Well, the other part could be on the primary side of things. That's where you got B+. You got a high voltage there. Your testing has been done testing the capacitors with, you know, what, a few volts. I'm not sure what your capacitance meter has in it for a circuit and what kind of voltage it has on it, but it won't be more than 9 volts. It may have a 9-volt battery in it. But in any case, it's real low voltage. There is a slim chance, and I've seen it, where if there's quite a bit of gunk, corrosion, or anything in these capacitor plates, that they can, on the B plus side, want to develop a path and start arcing through. Now, you really won't notice it too much, except the fact that it basically shorts out this side of the coil, so you have no signal getting through. It's basically the same thing as taking and just connecting directly across here, and you basically short out the coil, so then you don't get no signal through. That's a slim possibility. I have seen it, although I have seen it in where I have seen it, it was still getting a little signal through. But you could have other things going on at the radio, so that the signal seems to be almost non-existent. Now, that's why I use the scope. The scope's going to tell you if you're getting anything through it. Some other potential possibilities, although I don't really think it'll affect that first IF can that bad, but I believe, and I haven't went back and checked the video, but I believe that this 15K resistor you said was getting pretty darn warm. I may be wrong. That may not have been the one he was talking about. This is a screen dropper, and then this is the screen bypass cap. It goes up to the screens. It goes to the screen grid and stuff inside your 6K8, and feeds over and goes to the screen on this other 6U7, and then it drops down to ground by a 33K. I would be interested in knowing what the voltages are here on the screens. It's 105 volts. Do you have that there? This tube, to operate right, if you look up in the manual, it says it wants at least 100 volts. Anything below that, the tube may not quite operate like it should. Whether this is going to have a serious effect on this, I don't know, and the fact that you did pull the tube out and tried testing, and you still shown up not getting anything through, may not have anything, but this may have some of the problem of with your high voltage and your current draw and some of the things that's going on. If your screens actually are drawing too much current, it will change the way the plates operate. The cathode is going to give up only so much current. There's a max limit on these cathodes. So at a particular heater temperature. So if your screen, for whatever reason, start drawing too much current in any of the tubes, or if this voltage is way off, then it's possible to throw off your plate voltages, and they'll go high. A possibility. So I'd be interested in what these voltages are and see what's going on, and double check this 33K. Make sure that you got a 33K in there going to ground here at this point. Now, the main thing with this, again, is using an oscilloscope. It's sensitive enough that you're going to be able to pick something up, even with again, like the radio's not even on, and see a signal. At this point, again, don't worry about what frequency it is. To get an accurate reading of frequency, either the radio has to be operated and you need to feed it more into the grid, like right here, or even clear back here. Okay, so to get a more accurate reading of what frequency that IF can is going on. I mean, you can pick it up here, but the feed's got to be either here or even further back. That kind of helps take out some of the circuitry and allows the tubes to do their job in amplifying the signal and get a proper signal going into that. And then you can see what, if it's peaking where it should be and correctly. The other thing, but the big thing is by testing with the scope will give you, if there's anything getting through that can, it'll show it up. You'll see it. Now it may be very weak. The IF can could still be bad. This is your second IF can out of that I assume was out of the same radio. There is possibility that either grime, grump, or dirt, corrosion in the capacitors, any number of other things, or just some sort of weird catastrophic failure took out both IF cans or done some damage to them. So, you know, the way, you know, testing the way we're testing by plugging the signal right into the plate, if nothing else, to see if we can get a signal through it, using the scope, or pull the can out and do like I showed you here of hooking it up directly to the can without even being in the radio. Either way takes out any other possibilities. Now there is a slim possibility that this IF can and its inductance and the total impedance of the filter is not quite correct for a 6K8 tube. It should be close, but it's possible that it's not. But that would not block the signal. Worst case scenario, the tube don't amplify as good, so you just get a little. The signal's weaker, but it's still working, and you still will hear a radio signal. You'll still pick up your generator running into it, and so forth. So hook it up. It doesn't matter whether you leave the grid cap on or not. It doesn't matter whether you leave the tube in or not. Makes no difference. You can hook it up this way, or you can try hooking it up here into the grid cap and feeding it in. Don't worry about how strong the signal is. The big thing is just crank her up. Give her all she's got, because you're not doing an IF alignment. You're just trying to see if you can get a signal through that IF can. If with full power through it, if the tube's working, if the 6K8 is operational, is a good tube, then feeding the signal in, it should amplify. So you should be getting a signal through it. And you can check and make sure the tube's amplifying. What you do basically is you feed your signal into the grid and you take your scope and hook here. Again with the capacitor, even though the scope actually has its own capacitor when it's on AC. I don't like pushing it because you got 245 volts there. I like to block that. Although the peak to peak, if this thing's really amplifying good, can be making use almost the entire usage of this voltage. So the biggest thing is on your scope probe. Most people have scope probes that's got times 10 and times 1 switch. Flip it to times 10. That allows any scope to go up to 400 volts, full height, peak to peak, and then you should be perfectly okay. But you can check that and see if the signal going in and the signal coming out are at the same level or the signal coming out is less, or you're not even picking it up, then there's a problem with this tube too. But if it is amplifying the tube, then you can actually hook your signal here And just because you're not picking anything up here, it could be just more or less something going on with the IF can. So try feeding the signal in there, and you can, like I said, you can check it here and then check it here and see what you're getting and see what's going on. But if you feed the signal into the grid, you'll be more apt to be able to find your peak with it and kind of get a general idea if it's somewhere close to 455. Don't have to be dead on, but and you're not really going to be trying to adjust it. You'll wait until you actually get the radio working. Anyway, this video's gotten awful long, and I meant to get this up yesterday, but a lot of things came up and I didn't get a chance to. So I'm sorry about that. I went looking. I don't think I've got any 455s or even 460s per se. Possibly I might have one. So if you're completely out of IF cans, I might have one for you. I'm not sure. I'll have to do some checking. I want to make sure they're good. I don't want to send you something that's going to cause you further headaches. So, but doing this test will give you some pretty good idea of if you're getting anything through this IF can. Again, try it on the radio, try it with it powered up, try it with it not powered up, try hooking here, try hooking up to the grid cap, you know, again, hooking at pin 3, hooking to here. If all else fails, pull the can out and do like I showed earlier in the video on how to hook it up, and just check just the can. See if you at least get a signal through it. And and the big thing is that the signal does vary, it does peak. I don't care where it's peaking at, but at least peaks. So, you know, with it out, do all these tests, see what you come up with, make a video of it, and we'll go from there. Anyway, hopefully this helps you. Like I say, rely on your scope. It is a handy dandy thing for you to have, and it works good. And for not to try to make the video any longer, but to give everybody an idea, those who don't know, you've got a wave on here. How do I know what frequency that is? Well, my time base, now on this one here, it shows the time base here. See, when I flip it, you see the numbers change. Some scopes, it's marked out just like this one here, and you just go where the dot is. It'll be milliseconds. On the other side here, be microseconds, and you know, whatever it goes to. Both of these are per division. Each large square is a division. You look to figure out frequency. You pick up a convenient spot where the wave is intersecting, going across like this, or the other way like this. But pick a convenient spot. You can adjust your horizontal position to bring it right on there, and you want to look to identical spot. This will be the identical spot. This is a full wave right here. So these two are identical, and that's what you're looking for. And you count the divisions. So it'll be 1, 2, 3, 4. The little dinky marks, and I don't know if I can get into that. Yeah. These little small little marks right there are 0.2. So this one's 1, 2, 3, 4, 4.2, 0.4, 0.6, about 0.7. So 4.7 times this frequency, or this time, will give me the total period or the total time across here, I take that and find the reciprocal of it, divide it into 1, and that'll give frequency. And that's how you find frequency on a scope. If you don't have like a digital scope or something like that, which will give it to you. So anyway, I'm gonna go ahead and stop this video here. Hopefully that's enough information to kind of keep you going, and maybe we can, you can find something out. The biggest thing is with the scope, you'll find out for sure if you're getting something through that coil or transformer, and if you are, then we go from there. Try to figure out if it's even coming close to being the proper frequency or anything. It could be way off or something. That is the reason why you're not getting anything through. So anyway, I look forward to a video from you, seeing what you do find out, and we'll go from there and hopefully get this thing working. So I'll see you on the next video. Thanks for watching.